Hey, what is up, you guys? We are going to try flipping this classroom for a little bit and see how that works out for us. And we are going to start with Chapter 6, Section 1, which is all about operations on functions. Basically, what we're doing is adding, subtracting, multiplying, and dividing functions. And for some of it, it's really just as simple as combining like terms. For instance, if I want to add two functions, f of x and g of x, you might see this notation now. F plus g of x literally just means add the two functions together. So if I have a function f of x and a function g of x, and I want to add them, just take 3x and add 2x minus 4 to get 5x minus 4. Same thing with subtraction. This f minus g of x means take f of x and subtract from it g of x. So f of x minus the quantity, so be careful with subtraction. Make sure you distribute that negative to get x plus 4. Multiplication, same thing, f times g of x, multiply the two, so basically distribute here, and then division, f of x over g of x. Sometimes that's as far as we can go. We do want to make sure we take note of the fact that x cannot equal 2, because what happens if x equals 2? We're dividing by 0, and we can't divide by 0. So when you do division, you want to make sure you include that notation there to exclude any values that would make our denominator equal to 0. So let's look at a few examples. I'll wait for this to load. It's kind of slow. You can also speed these videos up and watch them in like 1.25 or 1.5 speed. I wouldn't go any faster than that. But all we are going to do here is take f of x and add g of x. So f of x is negative x squared plus 3x plus 1. And then I'm going to add to that g of x, which is 2x squared minus 5. Oop, oh, sometimes this does this, and then it drives me nuts. Okay. Sorry guys, this thing's annoying. Okay, 5, and then we can combine like terms here. So we have negative x squared and positive 2x squared, which would just give us negative 1 plus 2 is just 1x squared plus 3x, there's no other x's, and then we can combine this. Why is it going y? To get minus 4. So again, all you're doing is literally just adding those two functions together. And sorry if that was too fast, you can go rewind that if you need to. Let's see if they give us subtraction. So again, if we're adding them together, we're just combining like terms. So adding these two would give us negative 4x cubed minus 3x squared minus 6x plus 5, which would be that one right there. If we are subtracting these two functions, so f of x, f minus g of x, let's just do that really quick. F minus g of x, I take f of x and subtract the whole quantity of g of x. So be careful there. Make sure you're distributing that negative sign. So this, I'm going to rewrite this without parentheses. This will be minus a negative, so plus 4x cubed minus a negative, so plus 3x squared. And so this is basically our final answer, but rearrange it so it's in descending order, and that would give us, let's see, this one right here for our final answer. So that's addition and subtraction. Again, basically just combining like terms. For multiplication and division, we are also just doing these operations that we've done before. It's just with this new notation. So if I want to multiply these two functions, then all we're going to do is write them right next to each other. 4x squared minus 2x, so f of x times g of x. And then you will have to distribute. So negative x times, I think they did it this way, 4x squared times negative x, 4x squared times 5, negative 2x times negative x here, negative 2x times 5 would be here, 3 times 5 to get, or 3 times negative x to get negative 3x, and 3 times 5. And then again, combine like terms, and there's our final answer there. Now with division, of functions, f of x over g of x, we're literally just placing one over the other. Now if we can factor and simplify, we will, but in this case this won't factor. And so all we have is that we just literally put the top over the bottom and that's it, but also include any restrictions for the denominator. But that's all we're doing for dividing. Graphing, we're not going to worry about the graphing of the combined functions. But there's one more operation that is brand new, and that is what we call composition of functions. So composition of functions, the symbols we'll use, typically you'll see this symbol, kind of like a degree symbol, but in the middle. So we read this f of g of x, and what that means is we're evaluating the function f with the value of g of x. So the domain of g is the range of g, which is the domain of h plus just the range of f. Don't worry too much about that. But let's just actually do this really quick. Comes perception. Yeah, so some students read this as the word fog, but we can say fog, and also you can have g of f of x, but we'll just actually just do some of these. First of all, let's skip this one. We'll just do this. Okay, so if I want to compose a function, people struggle a lot with this when they're first learning it, so just pay attention here. I'm not going to worry too much of how the book does it here, but I want to find f of g of x and then also g of f of x, so we can do our composition both ways. So first of all, let's look at f of g of x. Essentially, all that's saying is I'm going to take my f function. So my f function is 2x minus 5. But in place of x, I'm going to leave parentheses, because in those parentheses, I'm going to put g of x, and g of x is 3x. So essentially, we're just taking the g of x function and putting it in for the x over here. So f of g of x, that is just this. We replace g of x into this x, and we get, what is that, 6x minus 5. And that's the composition, f of g of x. Now if I want to find g of f of x, then I'm going to take the g function, which is 3x, but in place of x I'm going to put parentheses, and in those parentheses I'm going to put f of x, which is 2x minus 5. So the composition here would be 6x minus 15. They won't always be the same thing. There is a special case if they are the same, which we'll talk about later. But all we're doing is taking one function and putting it in for the input of the other function here. And that's all we're doing for composition, really. The other thing to know is that these are both linear, so the domain is going to be, the domain and range would be all real numbers for both of these. So domain and range, all real numbers, domain and range, all real numbers, and then when we do the composition, those will still also be both all real numbers. Let's look at another example, because this is a little bit tricky, I know. Okay, so if we want to find f of g of x, then again, let's see here. If I want to find f of g of x, then I'm going to take my f function. But in place of that x, I'm going to put parentheses. So I just rewrote this function, but in place of x, I put parentheses. And in those parentheses, I'm going to put g of x, which is 2x minus 3. Now from this point, we will have to square this and take the opposite. So squaring this would give us 4x squared minus 12x plus 9. And then distribute the negative to get negative 4x squared plus 12x minus 9. Again, this we would have to FOIL out. 2x minus 3 times 2x minus 3, once it's all simplified, would be this right here. And then our final answer here. And then g of f of x, we'll use a different color for that. G of f of x means I'm going to take my g function, but in place of x here, we're going to put f of x, negative x squared. So this will be negative 2x squared minus 3 for the final answer there, which is right here, okay? So that is composition of functions, and we'll talk a little bit more about domain and range of that in class. As far as application of composition of functions, we'll look at a few of those examples in class tomorrow as well. So this will just give you a quick overview on those operations: add, subtract, multiply, divide, composition. Those are our 5 operations that we're going to be doing in this section. So hopefully you watch this and you are ready to practice some of this in class tomorrow. Have a great night, and I will see you soon.